All right, now that we have done a little bit of practice with our composite figures or our composite solids, we're going to go ahead and continue with the exact same math, basically, but we're going to do it in the context of an application problem. So here it says that we have Ben who carved out the inside of a tree trunk. And so if you look, you can see trees are basically cylinders, and so they sawed it, so they made those two bases parallel to each other, which is what makes it a cylinder. And so we have the area of the base multiplied by the height of the cylinder. So I'm going to go ahead and write that. That's going to be the overall volume. So we have a tree trunk, cylinder. We've got the area of the base multiplied by the height. So that's like the beginning volume. And then it says, since he carved out the inside, he left the hole in the shape of a hemisphere. And a hemisphere is half of a sphere, like perfectly in half. So that means that his carving skills are on point, because that would be very hard to do. So we're going to say subtract. I'm going to call it half of a sphere because I think that makes more sense. And this is the whole. And so that would be subtracting off the half of the formula for a sphere, which is 4/3 pi r cubed. And so when we subtract those, the whole cylinder minus the whole, that would tell us the leftover part of the wood that's still there. So it's telling us to write a geometric formula, which is basically what I did right here, to explain how he could find the leftover part. Now, one thing we're going to be careful of when we do this is we have the same variable written here twice, and we have to make sure that that variable represents the same thing. So when you carve out that hole, you have to think about, when he carved it, did he go all the way to the very edge of the tree trunk, or did he carve a little bit inside of that and leave like a little like an edge around, or like a frame kind of around the edge where it was just like flat wood, and then it went down into the hole. So I'm going to go ahead and rewrite this. I'm going to say this would be pi, and then the radius of the cylinder squared times h, minus 1/2 times 4/3 pi, and then the radius of the sphere cubed. Just to make sure that we know that those two values could be a little bit different. And so that is going to be the volume of the wood that's left over in the trunk. Okay, so let's go ahead and actually try this problem with some numbers in it. So let's say that the radius of the tree was 5 feet. And let's say that the radius of the hole is 4 foot 10 inches. So that means that the tree, all of this, is 5 feet. But then if you think about where the hole would actually be, they're leaving a little bit of kind of a frame around the edge. So the hole doesn't go quite all the way over to the edge. That would keep the edge of the hole being sturdy instead of chipping and breaking off at the top. And then we'll say that the height of the tree is 6 feet. Okay, so when we look at this, the radius of the hole and the depth of the hole would be the same thing, right? Because it's how far you go out from the center. And if it's a perfect sphere, then that would be the exact same amount. And so that means that I'm going to go over here and I'm going to say depth as well. The depth of the hole, the radius of the hole. Okay, so if we start to plug these numbers in, we have to be careful because we have units of measurement here that are in feet, and then this one is a combination of feet and inches. And so what we're going to do is we're going to take 4 feet 10 inches and we're going to convert it only into feet. And so this is a little bit new. I don't think you guys have done this on these calculators yet. But if you hit alpha y equals, you can go down to option 2, and that lets you plug in a whole number, such as 4, and then a fraction such as 10 inches out of 12. And what we're going to do with that, see, it simplified it for you. It made it an improper fraction. If I go ahead and hit to turn this into a decimal, so I hit the math button and then option 2. This is not a good decimal to use because we'd have to round it to use it. So that means I'm going to go ahead and just use that fraction, 29/6. Okay, so the volume of the piece of wood that's left over is going to be pi times the radius of the cylinder, which is the tree, times the height of the tree, minus 4/6. I just went ahead and multiplied those two fractions together, pi times 29 over 6 cubed. Okay, so what I'm going to do first is I am not going to plug in the pi's. I'm just going to do 5 squared times 6, 4 over 6 times 29 over 6 to the third. And I don't want to round yet. Ooh, this is messy. Okay, and now what I'm going to go ahead and do is I'll just subtract those. So I'm going to minus, I'm going to go up here and grab this. So I highlighted it, now I'm pressing enter. So that's 2, 4, 2, 1, 1, 3, 2, 4 pi. And I'm going to go ahead now and just multiply that by pi. Okay, so this is approximately 234.756 cubic feet. And when you look at the assignment for today, a lot of the problems say round the final answer to the nearest thousandth of a cubic foot. Thousandth is 3 decimal places. All right, let's go ahead and try the next one. So here, Anne carved out the inside of a tree trunk, leaving a hole in the shape of a cone. That would also take a lot of talent. So here we're going to do the same thing. So we've got the cylinder first, which again would be the tree trunk. And that would be pi r squared times h, right? Area of the base multiplied by the height, minus the cone, which is the shape of the hole. And the formula for the volume of a cone, I think I keep saying area, so I'm sorry. I'm so used to doing areas. This was a volume. We're going to do another volume. So the volume of a cone would be 1/3 times the area of the base times the height. And so we would be subtracting these. Now, they're very similar. You can see that you've got 1 in front of this and then 1/3 in front of this. We could kind of combine these like terms if the radiuses were the same. But just like we discussed before, the radius of the hole might be a little bit smaller than the radius of the tree trunk, just to leave some room so it doesn't quite go to the edge. So again, I'm going to say pi, I'll say the radius of the cylinder. I'm using cy because cone also starts with a c. So radius of the cylinder squared times the height minus 1/3 pi times the radius of the cone squared times h. And actually this h would be of the cylinder, that h would be of the cone, because there's no telling that the hole would go all the way to the bottom. In fact, if you were being smart about making a hole, you probably wouldn't make it go all the way to the bottom, because if you did, then it would go through. It'd be like a tree noodle. It would be stupid. Don't do that. So that's how we find the volume. Okay, so let's go ahead and think about this problem. So let's do, let's make the tree trunk have a height of 8 feet and a radius of 2 feet. And then we will say that the cone inside, and I wouldn't call it depth, I wouldn't call it height, I would probably call it depth, has a depth of 7 feet 7 inches, and it has a radius of 1 foot 8 inches. Okay. So 8 and 2, we've got that. With the other measurements, let's go ahead and put them in terms of only feet, not thinking inches. So 7 and then 7 over 12. Yeah, again, a decimal we don't like. One foot 8 over 12. A decimal we don't like. Okay, so when we do this one, we're going to have pi times the radius of the cylinder squared times the height of the cylinder minus 1/3 pi times the radius of the cone times the height of the cone. And that's our overall volume. So again, I'm going to type it without the pi, and the reason I'm doing that is so that I hope you guys can't hear that beeping. It's very obnoxious. I think, oh, that was 3:30. It's the end of class. 2 squared times 8. So I'm not typing in the pi because I want to make it easier to add these together, and that's easier when I don't have decimals to mess with. So 1/3 times 5/3 squared times 91/12. So 78.472, again, we've got cubic feet. All right, let's go ahead and just do the last problem. So Project Future Now invited startups to design a prototype of the first Martian habitat. One of the designs below would offer 92.9 meters squared, that's an area, of combined living space on the first and second level. So here we've got like the first level, and here we've got the second level. The first level will be installed 5 meters right underneath the surface of the planet. So this is kind of like a basement. So 5 feet. And we'll have the shape of a cylinder. The second level will be 6 meters above the surface in the shape of a cone. Very interesting looking living space. What will the volume of these living quarters rounded to the nearest thousandth of a meter cubed be? So if we look at this, when they say the living space, you guys have probably never been apartment hunting by yourselves, but if you go, they tell you like what the square footage of the apartment is, or they tell you the square footage of the house or whatever. So this would be the square meterage of the 2 floors. And since we know that these circles are exactly the same, then that means that the area of these circles is going to be exactly half of the living space. So half of the square meterage is up here and half of the square meterage is down there. So 92.9 divided by 2 is 46.45 meters squared, and that is going to be the area of the circle. All right, so we know that to find the volume of this living space, we have to have the area of the cylinder plus the area of the cone. Area of the cylinder plus the area of the cone. And so the area of the cylinder, that's the first level. Area of the cone, that's the second level. So the area of a cylinder is the area of the base multiplied by the height. The area of a cone is 1/3 times the area of the base multiplied by the height. And I'm going to go ahead and just plug this straight in my calculator. You could have plugged the other problem straight in your calculator, but I was using the video as an opportunity to kind of show you guys how to deal with pi, because a lot of students kind of struggle with how to plug those in well. All right, so 325 feet, 0.15 meters cubed. It said the nearest thousandth, which would be 3 decimal places. You can add a 0 on the end if you want, but you don't have to, just because this answer ended up only being to the 100th place, and that's totally fine.